Hello all, this is Mr. G and this is our warm-up for today's video. So pause the video right here, give these two problems a shot, come back when you think you got an answer. Three, two, one, let's go. It says determine whether the function g of x is concave up or concave down over the given intervals. We remember concave up is a u going up, concave down is a u going down. So let's take a look here. It's number one says over the interval when x is in between -6 and 2. So let's look at our x values going from -6 to +2. So we don't have to look at the whole function. We just care about the function that or what's happening in this function between those two values. So let's see, at -6 we're right here, going down, then up until it gets to x equals 2 right there. Well, if we ignore the rest of the function and just focus on the part that's highlighted in blue, that looks like it's concave up. Now that does not mean the entire function is concave up, just that one section, that one interval. Now let's take a look at the second one, which is from 4 to 9. So x goes from 4 to 9. So let's see. So at 4, g of x is right there, and then it's going like that till it gets to 9. Well, again, if we just focus on the green, that looks like it's concave down. Concave down. So this function, g of x, is a big departure from the quadratic functions we've been dealing with in this chapter. With the quadratic function, it's either always concave up or it's always concave down. But here we see a function where there's more than one curve, where for some parts of the function, over some intervals, it's concave up, and over another interval, it's concave down. Right? So there's a lot of different types of functions out there that can do different things. Well, let's take a look at our objective today. Today we're doing chapter 4, section 2.5. Obviously that section is not in our textbook. This is something I add into chapter 4. Our objective, after today we should be able to describe the graphs of quadratic functions. That's our goal for today. All right, let's take a look at our next slide. The first way we're going to be describing functions is as increasing or decreasing. Now, hopefully when you think of increasing versus decreasing, you think of something like this. An increasing line looks like this, and a decreasing line would look like that. But it's not as simple as just saying, oh, increasing always goes up and decreasing always goes down. Because if we look at our increasing line, that has an arrow pointing down. And similarly, if we look at our decreasing line, that has an arrow pointing up. So we need to be real specific about what we mean by, oh, it goes up or it goes down. Let me get this shade out of the way and scroll down a little bit. So f of x is increasing when it goes up from left to right. We always read from left to right when we're talking about a function. And similarly, f of x is decreasing when it goes down from left to right. Always going from left to right. So it's almost like we're on a little car going from left to right. Okay, here we're going up, we're increasing up. But over here, when we go left to right, we're going down. So always make sure you're going from left to right when you're talking about increasing or decreasing. But what if we apply that to a parabola? Is this parabola increasing or decreasing? Sometimes I have students say, oh, well, this is increasing because it's got two arrows pointing up. But that's not technically correct. This parabola is both increasing and decreasing because it all depends on what part we focus on. If we focus on this part of the parabola, well, that's decreasing. That's going down from left to right. That's decreasing. But over here, if we focus on this part of the parabola, going from left to right, that's increasing. That's getting higher as we go from left to right. So the question I have for you, where is the point where it switches from increasing to decreasing? Hopefully you're saying it's this point right there, the vertex. The vertex. So let's talk about that vertex right there. At the vertex, is this parabola increasing or decreasing? Well, it's doing neither. It's staying, how do I want to say this? The vertex is where it switches. So it's, okay, so we're, let me draw a box here. So let's imagine it's like at the roller coaster. So we start from left to right, okay, decreasing, 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 and then right there, just for a second, we're neither decreasing nor increasing. And then as soon as we get there, okay, now we're increasing, increasing, increasing. But right there at the vertex, we're doing neither. We're staying, just for a quick second, we stay constant. So as we're moving from decreasing to increasing. All right, now let's see how we can apply this to some examples. So here's example one. We've got this graph, and we want to represent the values of x for which f of x is increasing. All right, so for some of these, how do I want to say this? Sometimes students see this problem, these types of problems, and they're like, oh, immediately I get it. So maybe you won't need all the explanation I'm giving here, but in case anyone's confused, I'm going to try and break this down in the most simplest way possible, or the simplest way possible, I should say, at least the way that it makes sense to me. So whenever I see increasing or decreasing, that's when I think, okay, I'm going to imagine we're on a roller coaster here. So here's the little roller coaster car, and we're going to start from left to right, and we're going to think, okay, so as we go from left to right, obviously we start increasing. So we're increasing till we get to that point. So this is the section where we're increasing as we go from left to right. So it stops increasing right there. So essentially it's increasing whenever our x values are less than, let's see, what is the x value that corresponds right there? Well, it's 2. You see that right there. Let me undo that. So that means whenever x is less than 2, this function f of x is increasing. And that makes sense because if we highlight all of the parts of the function that where it's less than x is, where x is less than 2, we get a line that's going up from left to right. So this is one way we can represent it, just with an inequality. We can also represent it on a number line, which is what we have right here. Hopefully you remember this from 7th, 8th grade, but if you need a little refresher, since it's less than and not or equal to, I put an open dot on 2. And since x is less than, we shade to the left to represent that it's all the numbers that are less than positive 2. All right, now let's take a look at example 2. Same graph, but here it's saying, okay, now represent the values of x for which f of x is decreasing. Again, since we're talking about increasing or decreasing, I imagine we're on a roller coaster. Okay, start from the left, going up, 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 increasing, increasing. And now it's the fun part of the roller coaster where we're decreasing. So we start decreasing right here, right there at the vertex. And we're decreasing for the rest of the function. So we're decreasing anytime x is greater than 2. X is greater than 2. Now it's not greater than or equal to, because remember, at that vertex, at x equals 2, we're staying constant. Just for a quick second, we're neither increasing nor decreasing. And let's do this on the number line as well. So we put an open dot on 2 to show that 2 is not included, and then we shade to the right because x is greater than. That was supposed to be an arrow, but whatever. All right, let's keep on going. Let's do one more together, then I'll have you try one on your own. It says represent the domain values for which g of x is decreasing. Okay, decreasing. So I imagine we're on a roller coaster here. So going from left to right, we hit the function finally here, and we are decreasing. So right away we start decreasing until we get to the vertex. So the vertex is at x equals 8, right there, x equals 8. So that means we're decreasing completely on that side. So whenever x is less than or equal to 8. Less than or equal to 8. And we can graph that on the number line. So open dot on 8, shade to the left. Hopefully you're getting the hang of this. Try this one on your own. So here's example 4. I want you to represent the values of x for which h of x is increasing. 3, 2, 1. Let's go over it together. All right, so again, I imagine a roller coaster. I know it's stupid, but it helps me get the answer correct. I don't care if it's stupid if it keeps me from making a mistake. So we start out decreasing, decreasing. Oh, we hit the vertex, and from here on out, from there for the rest of the function, we are going to be increasing. So it starts increasing right there at what is that? X equals -4. So it's increasing. So we'll put the x and the -4, and it was everything to the right of that -4, which means the x values that are greater than -4. So on the number line, I put an open circle on -4 because it's not included, and x is greater than, so we shade everything to the right. And there we go. So that's the work we're going to do with increasing or decreasing, but there's one other way that we're going to describe our functions, and that has to do with positive versus negative. So here's a graph here, and the question is, at what points is f of x positive and negative? Now, before we move on, we have to make sure we really understand what f of x means. F of x is the function. It's representing the numbers we're getting out of the function, the output values, the range values, the y values. So when we say at what points is f of x positive, another way to think of that is, okay, at what points will this function have a positive y value? A positive y value. And if we look at that, that's going to be A, B, and C. A, B, and C. And if you don't believe me, let's take a look. A is -2, 7. B is, what is that, 0, 4. And C is 3, 2. Now, not all of these points have positive x values, but it was asking about f of x. x, the output, the range, the y values, and all of our y values are positive. So A, B, and C. Now let's take a look at when f of x is negative. Hopefully you can see, okay, so that's when the y values would be negative, so that would be E and F. If you don't believe me, let's just take a look. E is 7, negative 2. Let's move that over so we can actually see it. Of course, that would happen. There we go, finally behaved. And F is 9, negative 4. 9, negative 4, if I'm doing that correct, yeah. So again, the x values are positive, but it wasn't asking about the x values. It was saying where will the f of x values, the range values, the y values be negative, and they both are. So everything is included except for point D. What's going on with point D? Hopefully you're saying, okay, well, the y value is neither positive nor negative there because the y value is 0. That's 5, 0. Now the number 0, hopefully we know, it's not positive, it's not negative, it stands in the middle. It's the only number that's neither positive or negative. Unless there's some weird number I can't think of off the top of my head. But for the basic numbers, like you're talking whole numbers, integers, 0 is the only one that's neither positive or negative. So D doesn't fit into either of these categories. And it's important to realize that because the reason it doesn't fit is because it's on the x-axis. It's on the x-axis. So that's showing us that, the x-axis, that's what's separating the positive range values from the negative range values. So let's sort of get this in our notes. So functions, when we're talking about positive versus negative, f of x is positive when it is above the x-axis. F of x is negative when it is below the x-axis. And f of x is 0, neither positive or negative, when it is on the x-axis. So that's what we need to know. That's going to help us figure out when a function is positive or negative. All right, let's take a look at our next example. So we're going to represent the values of x for which f of x is positive. Now, we don't need to do, how do I want to say this? We're not talking about increasing or decreasing anymore. So we don't need to imagine a roller coaster car going from left to right. We don't need to do that for positive or negative. What we need to do is focus on the x-axis and say, okay, so what part of this function is positive? What part of the function is going to be above the x-axis? Hopefully you're saying, it's this part right there. That's the only part of the function that's above the x-axis, which means it's the only part of the function where the f of x values, the range values, will be positive. So to represent this with an inequality, let's see, it's going, the x values, because remember, we're talking about the values of x, and remember, values of x, domain values, all those things mean the same thing. So our x values, we're going from -1 to a +5. So the way we can write that in an inequality is, all right, it's the x values between -1 and +5. Now remember, we're not going to put or equal here on either of them. We're not going to do that because f of x is not positive at x equals -1 or x equals 5 because those points are on the x-axis. They're the zeros of the function. That's why they're called zeros, because f of x is 0 at those points. Where were we? Okay, now we need to put this on the number line. So we put an open circle on -1 and 5 because they're not included. And then let's see. This shading is all the points in between then. So we just shade all the points in between. And there we go. Let's take a look at another one together. Now we want to represent the values of x for which f of x is negative. Now this is the same graph. So, okay, we look here, we look there, and we think, okay, what parts of the function are negative, so below the y-axis? So that part's below the y-axis, and this part's below, what was I saying, y-axis? X-axis, below the x-axis. Sorry about that, everyone watching. Those are the only parts of the function that are below the x-axis. So we don't need the x-axis highlighted anymore. Well, okay. -1 and 5, those are still the points which are on the x-axis, which makes sense because it's the same parabola. So this is going to be kind of tricky to do as an inequality. I'm going to do this as two separate inequalities. So I'm going to say, okay, x needs to be less than -1, or x is going to be greater than 5. Anytime we have shading sort of separated like this, some shading on this side, some shading on that side with a space in the middle, I like to write that as a compound or inequality. two separate inequalities connected with an or. Where were we? Okay, now we just need to put that on the number line. So I put an open circle on -1 and an open circle on +5, and then we do exactly the shading we see in our f of x. They're shaded not in the middle, so we shade to the left there and to the right there, and we're done. Let's do another. How many more do we have here? Look ahead real quick. Just three more, just three more. We'll do one more together, then I'll have you try the last couple on your own. Represent the domain values. Now remember, domain values, same thing as the x value, so we don't need to change our strategy one bit. Represent the domain values for which g of x is positive. Okay, positive. So we're thinking above the x-axis, so let's just shade everything that's above the x-axis. So that this part's above the x-axis, and this part's above the x-axis. All right, that's always the first step. Now let's find the points where it's sort of separating the positive and negative. So it stops being positive right there, -8, and it stops being positive right there at -1. So we're going to need two inequalities here since the shading is separated. So let's do the one on the left first. So that's going to be x is less than -8, or x is greater than -1. Greater than -1. Now we're just going to take that and put it onto our number line. So -8 gets an open circle, and we shade to the left of it because its x is less than -8. And -1 gets an open circle since its x is greater than -1. We shade to the right, and there we go. Two more. I want you to try both of these on your own. So pause the video right here, give this problem a shot. We'll come back and do it together. 3, 2, 1. Let's go over it. Represent the values of x for which f of x is negative. Okay, negative means below the x-axis, so we're talking about this part of the function right there. So since the shadings meeting, or the two shadings are meeting, I guess we could say, there's not two separate shadings. We can just write this as one compound inequality, an end inequality, sort of connecting itself. So let's see, what is that? From -3 to 3. So x is between -3 and +3. And to graph that on the number line, we just go to -3, put a circle, +3, put a circle, and then shade in the middle, and we're done. Right, one more to go. Last one for this video. Again, try it on your own. Pause the video right here, come up with an answer, come back when you're ready to go over. 3, 2, 1, let's go. Represent the domain values for which g of x is positive. So remember, positive means above the x-axis, and hopefully you're saying, well, wait a minute. This function is always above the x-axis. It never goes below the x-axis. It never hits it, so it's never 0, and it never goes below it, so it's never negative. So the answer is just, okay, all reals. What are the x values, or excuse me, what are the domain values for which g of x is positive? All real domain values will make g of x positive. And to show that on a number line, we just shade everything, and that's it. All right, it's time for your assignment. So your assignment is going to be worksheet 4-2.5, numbers 1 through 3. Now, in case you don't have that worksheet, I'm going to show it to you right now. So these are the three problems. So number 1, get rid of that. Number 1, number 2, and number 3. Those are the three problems. Now, each of these problems are actually 4 different problems. So even though it's 1 to 3, it's actually 12 questions, because for each of these parabolas, I want you to represent when it's increasing, decreasing, positive, and negative. We're going to practice all 4 of those descriptions with all 3 of our parabolas. Hopefully this all made sense. As always, if you're confused or have any questions, need anything, let me know. Enjoy the rest of your day.